Hey guys, so we are getting into chapter 10 today, and I am going to start back with what we went over before break. So 10.1, we're going to go back over, and 10.2, and then we'll move forward. So 10.1 is our lines and segments that intersect circles. So these are the parts of the circles that we were labeling. So remember, your circle is a set of all points in a plane that are equidistant from one point. So we label that using the circle icon, and then we label it with the center of the circle. Remember, the center of the circle is that one point that is in the middle. It is equidistant from all of the other points in the circle. Then we have our radius. So the radius is a segment. Okay, so we're thinking about that. If we were writing it, remember that looks like this. Maybe it's something like that. AB, okay? So segment AB whose endpoints are the center and any point on the circle. So if I had this as my radius, so this one's labeled, okay, right here. So this would be A and B, so something like that. Okay, then we have our chord. Chords are just segments whose endpoints are on the circle. So again, we have a segment, so think about what that would look like. Maybe we pick our favorite letters. Those are DC this time. So that's D and C. Okay, so it's just a segment whose endpoints are on the circles. Remember that the diameter is a chord that contains the center of the circle. So this one right here goes right through the middle of the circle. Again, it is a segment because chords are segments. So maybe this one we use J and R. Okay, it doesn't matter to me right now because I'm just giving you examples. And that is all for that first picture. So if you guys want to see the difference there, the first picture has all of those definitions, and then the bottom picture has the others. So we're talking about a secant next. Our secant is a line. So when we write that with our notation, it looks something like this. AB, oh, those are already on there, so I don't want to use those. Let's use DC, okay? So here's D and C. Okay, so that might be my secant. Remember, a line has the arrows above it when it comes to notation. Then you have your tangent, which is a line, segment, or ray. So this one, remember, is the one with the arrows. This one has no arrows, and then your ray is the one with a single arrow when you do your notation. And it intersects the circle at exactly one point. So remember, this one's always on the outside of the circle. It's only going to intersect once. And then that one place where it intersects is called your point of tangency. So my point of tangency for this example is B. Okay, so what you're going to be doing in 10.1, remember, is just labeling pieces to start with. So tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of the circle. So the first part that we're looking at is AC. So right here, this is a radius of my circle, A to C. Okay, next part is AB. So all the way across, and it's going through the center of my circle. So it is a diameter. Remember that the diameter is also a chord, so keep that in mind if you're labeling things. Then we have ray DE. Okay, ray DE. So this part right out here, this is a tangent. Remember, that's where it only intersects the circle one time. There's my point of tangency at point B. And then the last one that I have is line AE. So line AE goes through the circle. So if I look back at my definitions, that is a secant. Okay, the other thing that is in 10.1 are my properties of those tangent lines. So remember, the tangent lines are the ones on the outside of the circle. Okay, so we have a couple. The first one is what kind of angle is created when I have a tangent line. So I see that little box there. So that is telling me I have some perpendicular lines, which remember give me those 90-degree angles. So I'm looking for something that's 90 degrees. Remember, this is where we also might see some right triangles happening. Okay, we could connect these lines to make a right triangle. So we do have 90 degrees if it is a tangent line. Okay, so this is tangent. The other property of tangent lines that we have comes when both tangent lines, so two tangent lines, meet at the same external point. When they meet at the same external point, these tangents are congruent. So RS would be congruent to TS. So I'd be able to set those equal to each other to solve for something, or know if this is, maybe it's 4, then this is also 4. Okay, so common external point means they are congruent. All right, so first example here says, is ST tangent to circle P? So I want to know, is this a tangent line? So the only way that we can do that, because the other one is not a tangent, it cuts through the middle of the circle, so this is not a tangent line, is to figure out whether we have a right angle right here. Okay. So in order to figure out whether that's a right angle, I am looking at this shape, okay, and I notice that that is possibly a right triangle. So if that's a right angle, this would be a right triangle. So I'm going to use Pythagorean theorem to help me see whether it is or is not a right triangle. So remember, if that is my right angle, then across from that there's my C value. Okay, so a squared plus b squared equals c squared. So I just said this is 37. Okay, and then I'm going to have to fill in the other two. And remember, it doesn't matter where they go. So you have a 35 squared and a 12 squared. Okay, so the next thing that you're going to do is actually find out what those values are. So I have 35 squared, which is 1,225. Then I have 12 squared, which is 144. And 37 squared, which is 1369. Okay, so what I want to do is I want to add those two together on the left there. And I get 1369 equals 1369. Remember, if they are equal, this is telling me this is a right triangle. So since I do actually have the right angle there, then yes, ST is tangent to circle P. Okay, we have just a couple examples left here as refreshers for 10.1. So in the diagram, it says point B is a point of tangent C. So that right away tells me I know I have a perpendicular line right there. Okay, so it gives me the right angle. Those are perpendicular lines because it says it is a point of tangent C. Then it says find the radius of circle C. So what I'm trying to find is this value, this R value. Okay. The hardest part, remember, about these is I have to remember that this whole thing is my C. This is C over here. Okay, so when I'm using my Pythagorean theorem, I know that C is actually 50 plus R. Okay, so 50 plus R right there. And then again, remember, it doesn't matter where A and B go, so I'm just going to drag those over here. So I have R squared plus 80 squared. Okay, so now that I have those all in my equation, I'm going to simplify as much as I can. So I have R squared plus 6,400 equals, and remember here I do have to actually FOIL these out. So I'm going to multiply these together. So the first thing I'm going to start with is 50 times 50, so I get 2,500. Then I have a 50R, R, and a 50R and R squared. Okay, so that's all FOILed out right there. FOIL. Okay, so now I'm going to start by trying to simplify as much as I can. So I'm going to subtract my R squareds. I notice that those cancel, so that's going to help me out. I'm going to put these like terms together. So I have 100R. Subtract my 2,500. So I get 3,900 equals 100R. And I'm going to divide that by 100. So my radius is 39. Okay. Now remember, anytime that you have a label in your problem, you should label your answer. So your radius is 39 feet. Okay, your last problem here is the second example of properties of tangents. Okay, it is your external tangent congruence theorem, which says if two tangents meet at the same point outside of the circle, then they are congruent. So I can set these two equal to each other and solve. Okay, so I'm going to go ahead and subtract my 4 from both sides and divide by 3. And I get that x equals 8. Okay, so your assignment will be on Clever, so make sure you're checking there for your assignment for 10.1. Thanks, guys.